Hello and welcome to Clean Code with Pure Functions. In this section, we'll try to demonstrate what pure function is and why we might prefer to use pure functions in the business logic part of our application. We'll implement a complex business logic case, the recommend book feature. We'll also try and refactor some of our existing code and finally implement a key feature, select book. The recommend book feature will do in a full-on pure function mode. Other parts will concentrate on certain aspects of the pure function approach. For the refactoring, we'll try and replace global state with parameters. For the select book, we'll try and receive all our dependencies, including functions, in our method parameters. We'll point out the advantages of each of these cases. We'll concentrate on approach is a spectrum, as is often the case in real-life situations. And we might choose to use only certain aspects of it for their merit in certain situations. With that, let's begin with pure functions. In this video, we'll try to define the pure function, its advantages and its shortcomings. First, let me start by saying that I'll be using pure functions and pure methods interchangeably throughout this and the next sections. The term that's generally used is pure function. And as you can see, if we search for pure method, the first result is a pure function definition. In C#, we mainly deal with methods which are functions attached to class definition. So please accept that everything we say about pure functions is also true for pure methods. So what is a pure function? Well, the main feature of a pure function is that it depends only on its parameters and does not mutate or depend upon any external state during execution. That's a bit abstract, so let's try and represent that as a block. It has an input and an output, and what happens inside does not reach out in any other way. A very simplistic example are the mathematical functions, like addition or multiplication. They receive all their input as parameters, and their output is their only connection to the world. Let's demo one such function in code. So we're back in Visual Studio, and here I've implemented the add function. All it ever does is receive two inputs and give back one output, the sum of the two inputs. This method is pure. Having a pure method has a lot of advantages, like repeatability. However many times we call the same function with the same input, we get the exact same output. Testability. We can easily test the function that receives all its dependencies as parameters. We need no mocks, we just need an instance. Readability. All we need in order to understand the function is right there. All dependencies and all logic. No need to understand other abstractions or go looking through other files. We also get cacheability. We know that calling the function with the same input will always yield the same output, so we can safely cache that. There is one problem with pure functions. If they cannot touch external state or any input-output, then how do we, the people, read the result from them? We need the other type of functions, the counterpart of pure functions. They can read and write to the console, files, networking, and generally perform input-output operations. These operations are what we call side effects, and the functions are side effect functions. These are what actually makes the software useful to people. Because if we only ever had pure functions, which can't read a file or output to the console or respond to an HTTP request, then no one will be able to see their work. So we do need both pure and side effect functions. I need to say this Employing side effects in a pure function renders that function no longer pure. And keeping pure functions in our core business logic is what we aim for, and keeping presentation logic separate. Let's show this add and log method. It has a couple of inputs, it has an output. It does basically what this function does, but it also console outputs. So that's a side effect which renders this add and log method not pure. Let's demonstrate this in action. So in the first part, we have done a couple of additions of 1 and 2. We want to show that all x, y, and z are equal to each other and equal to 3. And then we'll do the same for a, but with add and log, we'll demonstrate that again x and a are 3 and they're equal to each other, but there's the side effect. So let's show that. So there you go, x and y and z are all 3 and they're equal to each other. And now we run the add and log function to calculate the result for a, and it has the observable side effect of writing to the console. This is no longer pure. So the two methods return exactly the same result, but one has observable side effects. While calculating the result for a, we've logged to the console. This makes our core logic tightly coupled to the console. And the console has actually nothing to do with calculating a sum of two numbers. So it should not be used in that function. It should be done in its own place, our presentation logic. We can easily do logging right here in the presentation part of our program.